Okay, so that was kind of cut off in the last video. This section is going to go 3 videos. Sorry about that. But I was kind of talking about reviewing trig, and if you have a triangle, right triangle, let's call this theta, this angle theta right here, and then we can start labeling all these sides. Like this was the opposite side to theta. This is the hypotenuse. This side right here is going to be the adjacent side to angle theta. And that's important to know for our trig ratios, because if I'm talking about the tangent ratio of theta, then I'm talking about the opposite side, that number, that length, over the adjacent side. If I'm talking about the sine of theta, I'm talking about the opposite side over the hypotenuse. And then if I'm talking about the cosine of theta, I'm talking about the adjacent side over the hypotenuse. And we're going to need to use one of these, actually two of these, to find the side length and the radius of this hexagon. And here's how. So a regular hexagon has an apothem of 10 units. So let's draw that first. So I'm going to do a hexagon best that I can. I have a center here. I always want to think of these always as inscribed. So I kind of have my circle, that goes around. Remember this, the center to all the vertices are the radius or the radii of this. I don't know what that is. So the radius, I don't know. It's unknown. And the side length, which I've been doing in red, I'll stick to that, I also don't know. And I gotta find that. What I do know is the apothem. And remember, the apothem is this segment that drops from the center to the side length that creates a right angle. It's the height of the triangle. Now, before I kind of break this down, I want to talk about, this is why we need to know central angle. So we have 6 triangles in here. What is the central angle? Well, remember, we do 360 divided by 6. Each one of these angles, I'm going to do it in green. Each one of these angles is therefore 60 degrees. So this whole angle here is 60 degrees. Now I'm going to kind of expand this smaller triangle here because I really want to take a closer look at this. This triangle has half of a side length we know it has an apothem. We did in blue. The apothem's here. The apothem is 10. We were given that information. And the radius is the hypotenuse of this right triangle. And for now, I'm just going to add it. So half of the side length. So the other piece of information I also know from the central angle is if this whole thing's 60, then this part of it is going to be half of that because we're splitting it in half with the height. This is going to be a 30-degree angle here. And now we're going to use trig to figure out the radius and this side length. I'm kind of nervous actually writing half the side length. We'll double it to get this total side length here eventually, but okay. So what I have here from the 30, remember the 10, this is my adjacent side. Sorry, my writing is tough on this. The side length this is my opposite side to that 30 degrees. And then hypotenuse is always hypotenuse. So what trig ratios am I going to use to be able to find this opposite side and the hypotenuse? Well, the one that I can't use is sine. Because the sine of any angle, let's just use theta again, would be the opposite side over the hypotenuse. Well, I don't have either of those lengths, so I can't use sine. So I either got to use tangent or cosine. And let's see what happens here. Let's just try to set up the tangent ratio. So tangent, the angle I'm going to use is this 30-degree angle. And remember, back up with those notes, tangent is opposite over adjacent. Well, the opposite side, I don't know. I'm just going to say opposite. It ends up being that side length in red. Let me stick with that, just so you can see. So that's that opposite side. And then the adjacent side is 10. And I knew that piece of information. So now to solve for this, I want to multiply both sides by 10. So you're going to find that the opposite side, which ends up being half of our side length, opposite side is 10 times tangent of 30. And I'm just going to go to my calculator real quick. Clear this out. I'm in degrees. We do 10 times tangent of 30. And I get 5.7. So I'm going to go to my answer presentation. Okay. And so if I want that length of the side, I need to double that. Because remember, this is just half of what this is, and we're asked for that side length. So I actually need to take 2 times the 10 times the tangent of 30 degrees. So if I go back to my calculator, I need to finish this by also multiplying it by 2. And so I get 11.5. If I go to my answer presentation, that's what I got, 11.5. Good to go. So go back to my notes. The side length that they asked me about is 11.5 units. Okay, now I need to find the radius. Well, radius is the hypotenuse. So I'm going to use the cosine ratio for that. I know that the cosine of 30 degrees is the adjacent over the hypotenuse. Well, in this case, the adjacent side is 10. I don't know the hypotenuse. What I would do to solve this, I could multiply both sides by the hypotenuse. So I'd have hypotenuse times cosine of 30 degrees. Hypotenuse would cancel on this side. But then I need to solve for the hypotenuse, so I end up dividing 10 by the cosine of 30. So hypotenuse is going to equal this in my calculator. And remember, the hypotenuse is actually the radius back here. So let's go to the calculator real quick. I'm going to say 10 divided by the cosine of 30 degrees, 11.5. Got it, right there. So it looks like my hypotenuse and my side length are the same. So hypotenuse, or the radius, sorry, which is that radius, was also 11.5 units. And now lastly, we need to find the area. And I'm going to take that down here. So the area, remember, is taking the area of a triangle, which is the base times 1/2 the base times the height. But remember, the height we're saying is the apothem, and the base is the side length, s. And then we need to multiply it by the number of triangles we have. So we have half. We found the apothem to be, we go back up, we were given that was 10. What was the side length we found? We found the side length to be 11.5. And then this is a hexagon, so we need to multiply it by 6. So I'm going to plug all that into my calculator. I probably can't remember all that. So it was 1/2 times 10 times 11.5 for the side length, and times 6. 345 units squared. 346.4. All right. So I got 346.4. Let me just check again. So they had 346.4. I had 345. I think that should work. All right, so the area ends up being 345 units squared. And that is it. So this is challenging stuff, so be sure, if you're in my classes, doing those Google Meets, come online, ask questions. I'll go over more of these. Of course, reach out to Mr. Kluznik as well, because we just have a few more sections left for the year. So hang in there. Take care, everybody.